A Pocket Guide for Basic Statistics, Continuous Data and Research by Filippo. First of all, we have to point out what are continuous data and systematic reviews. Continuous data refer to data that can be measured. This data has values that are not fixed and have infinite number of possible values. Some example of continuous data would include the height, the weight, or the BMI of the age of a person. Or in the outcome statistic, it includes like the prompts. Prompts are continuous data. Systematic reviews synthesize the evidence on a topic using critical methods to identify, define, and assess research. From a statistical point of view, systematic reviews compare the quantitative results of original research which investigated the same endpoints. For example, systematic reviews will investigate the outcome of a specific treatment for a pathology, or they compare two different treatments or 3 or 4 for the same pathology. The first step for a proper statistical investigation is to analyze data distribution. The Saffir-Wick test is a test of normality in frequentist statistics. So it will investigate whether your data is normally distributed or not normally distributed. In this case, if the Saffir-Wick test, the P is less than 0.05, data will be normally distributed. On the other side, if it's more than 0.05, data is not normally distributed. From a more strictly technical point of view, the way of expressing the variables change according to the distribution. In parametric statistics, we use mean and standard deviation. In non-parametric statistics, we use median and interquartile range. So first, we check the data distribution using the Saffir-Wick test. Second, we check how to express values in parametric statistics using mean and standard deviation. In non-parametric statistics, using the median and interquartile range. And now we are clarify how to check the p-value, so to check whether data is statistically significant. But what is this p-value? The p-value in null hypothesis significant testing is the probability of obtaining test results as the results observed, under the assumption that the null hypothesis is correct. So basically it means that if the p-values is significant, it means that if we redo the same analysis under the same assumptions, we will obtain the same results. Reporting p-values of statistical tests is common practice. The trend in the actual literature is to use also the confidence of interval and replacing the p-values, but still the p-value is the most common used tool to evaluate the statistical significance of values. In parametric statistics, we use the student t-test if we are comparing two groups, or the analysis of variance, so the ANOVA test, if we are comparing more than two groups. In this respect, we have to point out that if we want to evaluate the improvement of a group during the follow-up, we use the paired t-test. If we are comparing two different groups, we use the unpaired t-test. When we use the one-tailed or two-tailed test, it depends on the original claim in question. A one-tailed test looks for an increase or decrease in the parameter. So for example, like prompts can increase or decrease. In a two-tailed test, we are looking for the change in the parameter. In non-parametric statistics, we use to compare two groups the Mann-Whitney test, or if more than two groups, we use the Cruxwell-Wallis test. Now we are checking the analysis of continuous data in meta-analysis. Meta-analysis compare the quantitative results of head-to-head comparison research. This is different from systematic reviews, which compare the, for example, treatment A at different follow-up to check for their increase, or treatment A versus treatment B versus treatment C for the same pathology. Meta-analysis, they include all head-to-head studies, comparison studies, to summarize the evidence. From a statistical point of view, meta-analysis should follow the recommendations of the Cochrane Handbook for Systematic Review of Interventions. Continuous data should be analyzed using the inverse variance method and mean difference effect measure. What is the inverse variance in statistics? In statistics, inverse variance weighting is a method of aggregating two or more random variables to minimize the variance of the weighted average. It means that each variable is weighted in the inverse proportion to its variance. A practical is a weighted average, because some studies, they include lot of participants, big population, big sample size, they have more weight, more impact on the outcome. The mean difference effect measure is the difference of the arithmetic mean of both groups. Heterogeneity in meta-analysis is important to be evaluated. Heterogeneity refers to between study variabilities in outcome. The most commonly used method to evaluate heterogeneity are the chi-square test and the Higgins E-square test. So, if the chi-square is not statistically significant, it means that there is no statistically significant heterogeneity. If the chi-square test is statistically significant, it means that there is statistically significant heterogeneity. To quantify the heterogeneity, we use the Higgins E-square test. As shown in the slide, the Higgins square test, basically from 0 to 50%, the heterogeneity is low to moderate, and from 50 to 100%, the heterogeneity is moderate to high. The heterogeneity refers to data variability, so high heterogeneity, and its data should be highly biased. Funnel plots are used to assess risk of publication bias in meta-analysis. A symmetrical distribution of the referral points in the plots is related with low risk of publication bias, whereas more asymmetrical distribution indicates high data variability, so high risk of publication bias. However, to objectivate data dispersion, there are some tests available. The most used test is the Egger test. If Egger test is significant, this means that there is a statistically significant asymmetry. So if the P of the Egger test is less than 0.05, high data variability is detected, and so high risk of publication bias is detected. If the P of Egger test is higher than 0.05, there is no evidence of statistically significant asymmetry. This doesn't mean that referral points are symmetrically distributed, but it means that at least there is no statistically significant asymmetry. So it's important in systematic reviews that the risk of publication bias is objectivated using funnel plot and Ecker test. Thank you very much for your attention.